Welcome to Learning with PPS. So in the today's video I'm going to discuss how to solve the problems regarding deadlock. In my previous video I have shared the basic definition of deadlock, how we can avoid the deadlock, how we can prevent the deadlock from the system. Like that I have discussed. Okay, in this video I am going to discuss about the numerical problem by applying the banker's algorithm. So dear students, this is the problem they will give. Okay, in case of gate examination, set examination, net examination, definitely one problem will be asked under the banker's algorithm. So in the banker's algorithm they give like that. From the problem we can identify that we have four processes, that is P0, P1, P2, P3. These are all available resources. Three instances A, B, C. Maximum resources needed to the completion of particular process. Suppose if we take P0 now, we need 8 instances of A, 6 instances of B and 3 instances of C. These are all the currently available resources, that is 4, 3, 2. Okay. So from the problem we should identify all those things. So as we discussed in the previous video, the banker's algorithm is a combination of safety as well as safety algorithm and resource request algorithm. Resource request algorithm, which means resource request algorithm. Okay, so it is going to determine whether the particular resource is granted or not. Safety algorithm, which is used to determine whether the system is in safe state or not. So in the previous video we have discussed these are all the data structures we needed to know while we are applying the banker's algorithm. Available, which means currently available resources, maximum resources needed for the completion of the particular process, allocated resources, already allocated resources, need, what are all the currently, what is the need of the particular process. Okay, so these data structure are most important because yes, you know that actually in the previous slide also I have shared the problems, right? So in the problem itself they have mentioned the three data structure. One is allocation, maximum and the need and the available resource. So that is most important for applying the banker's algorithm. So first step, you have to find the need matrix. How we can find the need matrix now? How we can find the need matrix now? It is very easy to find the need matrix, which means need is equal to max minus allocation. Need is equal to max minus allocation. So max in the sense of if, for example, if you take process, if you take process if you take process P0 now, which means process P0. So the need of the P0 is allocated max minus allocated 8, 6, 3 minus 2, 1, 0. Okay, so we get 6, 5, 3. Like that we should subtract the maximum minus allocation. So we will get the need matrix, easiest one. Second step, we need to find the safe sequence. Okay, for that, for each and every process we need to check whether the particular process is satisfied with available resources or not. So as we know that available resources are 4, 3, 2. What is the need of P0 now? 6, 5, 3. So we need to check the conditions. Need less than or equal to available. If the condition is false, we can't execute P0. So we can proceed with another process, that is P1. What is the need of P1? 8, 2, 1. Available resources are 4, 3, 2. Obviously P1 is not satisfied with available resources, so we can't execute P1. Okay, next process P2. What is the need of P2? 513. Available resources are 432. So now we can check need less than or equal to available process. So we can't execute because P2 need A resources as 5, okay, but available resources are only 4, so we can't satisfy the condition. Okay, for P3 need is 1, 2, 2, available 4, 3, 2. So P3 process is satisfied with available resources. Okay, once the condition is satisfied, now we can proceed with P3. After the completion of P3, P3 will return all those resources, so that we should update the available resources. So available is equal to available plus allocation. Already available resources 4, 3, 2. Okay, already available resources 4, 3, 2. Yeah, already available resources are 4. Yes, here 4, 3, 2. Allocated resources 3, not 1. Upon the completion of P3, now the available resource will be 7, 3, 3. Okay, from the next iteration onwards, we should consider the available resources as 7, 3, 3. Okay, so next iteration, now available resources are 7, 3, 3. Okay, now so need 6, 5, 3. Available resources are 7, 3, 3. Okay, A, C resources are satisfied, but for B we need 2 resources, so we can't proceed with P naught. Same scenario is followed on the P1 also. So P2, the need of P2 is 5, 1, 3. Okay, the need of P2 is 5, 1, 3. So yes, here, so 5, 1, 3, available resources are 7, 3, 3. So now we can satisfy the condition need less than or equal to available. So now we can execute P2. Already I informed that, right? So whenever the condition is true, we should update the available resources. The condition is satisfied, okay, we should update the available resources. Okay, so update the available resources like available is equal to available plus allocation. Already available resources are 7, 3, 3. Already allocated resources 0, 2, 0. So upon the completion of P2, we will get 7, 5, 3 as available resources. Now we can check the condition of P1. Okay, sorry, P naught. So P naught, the need of P naught is 6, 5, 3. Available resources are 7, 5, 3. So now the condition is satisfied, so we can execute P naught. So upon the completion of P naught, then the available resources will be updated like available is equal to available plus allocation. Available 753 plus allocation resources 210. Where we can take available resources, where we can took available resources now from the table. Okay, from the question itself they gave, right? So 210 are allocated resources. Now new available resources are 963. So for P1, yes, for P1 now we can satisfy the condition. What is the need of P1? 8, 2, 1. Available resources are 963. Okay, so now we can satisfy the need of the P1. Now we can execute P1. We should update the resources. Okay, so available is equal to available plus allocation. So now available resources are 963. Allocated resources are 1, 2, 3. So upon the completion of P1, we will get 10, 8, 5 as available resources. So this is the safe sequence. You should keep in your mind, if the system is in safe state, we can have more than one safe sequence. So now the safe sequence is P3, P2, P0, P1. Okay. In some questions they will ask what are all the total number of instances. How we can identify now? It is easy. So already allocated resources plus available resources. Suppose for A now, already previously allocated number of instances are 6. Available resources are 4. For B, already allocated resources 5. Available resources 3. C, already allocated resources 3. Available resources 2. So 5. So upon the completion of the process, upon the completion of all those process, we should get available resources as 10, 8, 5. Then only our answer is correct. Otherwise we did any mistakes, we did some mistakes on the solving of the problems. Okay, so up to this deadlock problem is cleared. For 16 mark and 8 marks now, we should write elaborately for each and every iteration. We should mention for some for competitive, in case of competitive examinations, from the table itself we can identify whether we can satisfy the need of P1 or not, P2 or not, P3 or not, because they won't ask any explanations. They just we just pick the correct answer from the options. Okay, so up to this video is over. So next video will be the get previous year questions on the deadlock problems. Okay, so those who are not subscribed my channel, please subscribe my channel. This is useful channel for you. So yes, don't forget to share and comment. If you have any doubt, please share your comment. We will discuss in the comment section. Thank you for watching.